Today we will talk about vapor pressure. Our question of the day is when molecules of the same type have strong attraction for one another, what are the resulting properties? Vapor pressure is the willingness of a solid or liquid to evaporate and become a gas. Basically, when liquid molecules have enough energy to evaporate, they will have to push against the atmosphere to break through the surface. Their strength is called vapor pressure. When a lid is on a container, the liquid inside still tries to evaporate. However, there is gas in the empty space on top of the liquid. This means that as temperature increases, vapor pressure will also increase because the particles have more energy. Let's have a look. Which of these will have a higher vapor pressure? When you evaporate water or when you boil water? Well, boiling water will have a higher vapor pressure. This is because more water particles have the energy to become a gas. A substance with a high vapor pressure will really want to evaporate and become a gas. It will have a low boiling point and weak intermolecular forces. This is something like acetone, which is nail polish remover. If a substance has a low vapor pressure, it tends to stay in the liquid phase and doesn't really evaporate easily. These are substances with high boiling points and strong intermolecular forces keeping them together. The boiling point of a substance occurs when atmospheric pressure is the same as vapor pressure. This means that you can boil any substance at any temperature so long as you adjust the pressure. Try watching the video linked in the description for an example. The normal boiling point is the temperature at which a substance will boil at STP. For water, this is 100 degrees Celsius. Now, pause the video and try the show what you know questions. You may resume the video and check your answers when you are done. In problem 1, we need to put the following samples in order of increasing vapor pressure based on their temperatures: 100 degrees Celsius, 25 degrees Celsius, 400 degrees Kelvin, and 273 Kelvin. To do this, we will need to convert all four numbers to the same units. So let's convert to Kelvin. To do this, we will take the temperature in Celsius and add 273. So 100 degrees Celsius becomes 373 Kelvin. 25 degrees Celsius becomes 298 Kelvin. Meanwhile, 400 Kelvin and 273 Kelvin are already where we need them to be. So we put all of these in order from least to greatest, and we get D, B, A, C. For number 2, we're going to put the following compounds in order of increasing vapor pressure based on their normal boiling points. Notice how each of these normal boiling points is given in degrees Celsius. So acetone is 56 degrees Celsius, ethanoic acid is 108 degrees Celsius, and propanol is 97 degrees Celsius. We also know that water's boiling point is 100 degrees Celsius. Remember, vapor pressure will increase as boiling point decreases. That means that in order we have G, E, H, F. Now, for 3 through 8, we will determine which has a higher vapor pressure. For number 3, a substance that evaporates slowly or quickly. Well, substances that evaporate quickly have higher vapor pressures. Substances with low boiling points tend to have high vapor pressures. Substances with weak intermolecular forces tend to have higher vapor pressures. Substances that take a short time to boil have low boiling points and therefore have more vapor and more vapor pressure. Substances that are liquid at room temperature have weaker intermolecular forces and therefore have higher vapor pressure. They evaporate more readily. For number 8, you are comparing 45 degrees Celsius, which is 318 Kelvin, to 300 Kelvin. The lower boiling point of 300 Kelvin is going to have the higher vapor pressure.